Hello and welcome to Mathmaster. In this video, we are going to learn the various kinds of operations on sets. Okay?
So the question is this a new concept in mathematics? No, it is not a new concept. We have already studied about so many operations in mathematics earlier, like addition, subtraction, multiplication, and division. All these are operations that we have already studied in elementary mathematics, and we have been using these operations till date. Okay. So, what's new in the operations that we are going to study today? We are going to study some special operations that we will use in set theory. Okay, what are they? The operations are as follows. So, in set theory, we are going to discuss about the operations that are union, intersection, difference, symmetric difference, and complement. Okay. So, what is the actual meaning of operation? Okay, we can think operation as a machine. Okay, let operation be a machine. Okay, what is the function of a machine? What we do is we put some raw material. Okay, we put some raw material and the machine gives us some product. Likewise, in operation, here what we will do is we will provide it some sets, okay, and it will return us with another set. Okay, this is basically the function of a operation. Okay, so let us discuss the operations one by one. The first operation is union. Okay, so what do you mean by union? Union is defined as follows. Let A and B are two sets, then the union of A and B is defined as a set whose elements are either belongs to A or belongs to B or to both. Okay, let us understand this by taking an example. Let A be a set where the elements are 1, 2 and 3 and B be a set where the elements are 3, 4 and 5. Okay, then what will be A union B? A union B is also a set that will have the elements that belongs either to A or to B or to both. That means it will have all the elements of A and all the elements of B. Okay, so it will have all the elements of A and all the elements of B. Look at here, 3 is the common element between the set A and set B. So this union also have the element 3, but we will not write it two times. We will write it only once. Okay, so this will be the union. Here you pick any element that will be either in set A or set B or in both the set B. We denote the A union B set as like this by putting this symbol. This symbol means union. Okay. In general, what do you mean by union? Union means we use the word union in a sense of addition or combination. Like we say that European Union. As you know, European Union has 27 countries. That means 27 countries are united to form the European Union. Okay, that means we can say that it is a combination of 27 countries. Likewise, here also we are using the word union. It is a combination of set where the elements are either belongs to the first set or the second set. Okay. So how can we write it in set builder form? We can write it in set builder form as follows. A union B equal to X such that X belongs to A or X belongs to B. What you have to notice here is you have to observe the word or and properly. Okay, where we are using the word or and where we are using the word and. Okay, that is the most important part in this topic. If I say X is an element that does not belong to A union B, then that ultimately means X is not an element of A and also it is not an element of B. Okay, this is clear. Now, how can we draw the Venn diagram for the union of two sets? Now, let this is the universal set. Let U be a universal set and A and B are two subsets of this universal set. Okay, then we can represent it by drawing two circles. Let this one is A and this one is B, and this is the common region. Okay, then the A union B will be the total, this one, this region will represent A union B. As you can see here clearly, any element that belongs to A is also an element of A union B. So we can say that A is a subset of A union B, and the similar case is for set B. So we can also write B is a subset of A union B. Now another property, let A is a subset of B. Okay, let A is a subset of B. Then what will be A union B? If A is a subset of B, then what will be A union B? Let us take an example and answer this. Let A is equal to 1, 2, 3 and B equal to 1, 2, 3, 4. Okay, here you can clearly say that A is a subset of set B. So A union B will be the elements that belongs to either A or B. That means 1, 2, 3 and 4. Here you can clearly see that this is similar to the set B. So we can say that if A is a subset of set B, then A union B is the set B. Okay. Now let us take an example. Okay. So A is a set where X is that X equal to 2n plus 1, where n belongs to Z. That means A is a set of odd integer and B be a set of even integer. Then we need to find A union B here. What will be the union? Here we can write it like this. This will be equal to, or it is the set of integer. Now let A1, A2, A3, likewise so many sets are there. Then the union of all these sets can be represented as like this. Okay, I equal to 1 to n. N means the number of sets, A1, A2, A3, like this. Okay, AI. Okay, which will be equal to A1 union A2 union A3 union dot 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 union AN. Okay, like this. We can take an example here. Let A1 equal to 1, 2 and 3 and A2 equal to 4, 5, 6 and A3 equal to 3 and 8. Then A1 union A2 union A3 will be 1, 2, 3, 4, 5, 6 and 8. A1 union A2 union A3 can be written as the set that is having element 1, 2, 3, 4, 5, 6, 8. Here you can see that any element of this set is also an element of either of A1 or of A2 or of A3. So I think the concept of union is clear. Okay, next we will study about the intersection. We often say that when two lines cross each other, we say that the two lines are intersecting at this particular point. Let this is line L1 and this is line L2. Then we say that L1 and L2 are intersecting at the point O. Then what we mean by this statement? We mean that L1 and L2 have the common point O. Okay, they have some common property. What is that? That is, they have the point O as common. So from here we can derive one thing, that intersection is connected with the word common. Okay, so let us define the intersection of two sets. Let A and B are two sets, then the intersection of A and B is the set of all elements that belongs to both A and B. What the statement is saying, let us understand it by an example. Let A be a set where the elements are 1, 2, 3 and B be a set where the elements are 2, 3 and 5. Then A intersection B will be the set of the common elements between set A and set B. Okay, so here you can see that 2 and 3 are the elements of A as well as B. Hence, the intersection of A and B will be the set of elements 2 and 3. Okay, this is the intersection of A and B. How can we represent it? We denote it by this symbol. Okay, this one is for intersection. Intersection means the common elements between the two sets. So clearly X belongs to A intersection B implies X belongs to A and X belongs to B. In case of union, we have used the word or, but here we are using the word and. So this one is very important in this topic. So and means, in this case it is necessary that the element in the intersection set is must be in both the set. Okay, hence we are using and. While in case of union, the element may be either in A or in B. So we are using or in that case. So this is clear. Now as you can see here, 2 is an element of A intersection B and 3 is also an element of A intersection B. And here you can say that 2 and 3 are also elements of A and B. So I can say that A intersection B is a subset of A and also A intersection B is a subset of B. Okay, so we can say that A intersection B is a subset of both A and B. Now what if A is a subset of B? Okay, for example, A equal to 2, 4, 6, 8. Okay, and B equal to 2, 4, 6, 8 and 10. Okay, then here you can see that A is a subset of set B. Hence, A intersection B will be the set of all elements that are present in both A and B. So the common elements are 2, 4, 6 and 8 and this set is similar to A. So we can say that in case of intersection, if A is a subset of B, then the intersection of A and B will be equal to A, and in case of union it will be the superset. Now what will be the intersection of more than two sets? Let A1, A2, A3, all these are sets. Then the intersection is denoted by this symbol I equal to 1 to n AI. Okay, where n is number of sets we are operating. And this will be equal to A1 intersection A2 intersection A3. So let this one A this one is B, and let C equal to 2 and 3. Then the intersection of A, B and C will be the set having the element that is common to A as well as B and C. We can see here 2 is the only common element between A, B and C. So A intersection B intersection C will be the singleton set having the element 2.
So how can we represent the intersection in Venn diagram form? Let A and B are two sets, then the intersection will be like this. Let this is set A and this is set B, then the intersection is this common region. This is what? This is A intersection B. Okay. So what if A and B are disjoint? Okay. If A and B are disjoint, then A intersection B will equal to 5, because if A and B are disjoint, then there are no common element between A and B, and hence the set of their intersection will be 5, and we can represent it in Venn diagram by drawing two circles that are having no common region. Okay, this is set A and this is set B.